Hi, today I will discuss minimization FA. In minimization FA, what we do, we try to minimize the number of state. How we will do this? First, find the unreachable state and remove them. Second, find the equal state and remove them. Then how we'll find the equal state? There are two algorithms for finding equal state. First one is state equivalence method. Second one is table filling method, or it's called Moifel-Nerod theorem. You can use any one. I will discuss both. Whichever you find easier, you just use that. The FA which is free from unreachable state and equal state is called as minimized FA. Now I'll discuss state equivalence method. Two state P and Q are equivalent. If del on PW belongs to F, then del on QW belongs to F. Means if same string P is going to some final state, then Q also go on same string to some final state. And if del on PW belongs to non-final state, then del on QW should belongs to non-final state. If P on transaction W is going to final, then Q on transaction W should go to final. If P on transaction W is going to non-final, then Q on transaction W should go to non-final. Then we will say P and Q are equivalent. All these states are divided into two partitions, final state and non-final state. And it is denoted as P0. In some book, you will find pi 0, or it is called as zeroth equivalent. If W length equal to 0, it is 0th equivalent. If W length equal to 1, it is 1th equivalent. If W length equal to n, it is nth equivalent. We will find the equivalent till two equivalents are same. When two equivalents are same, we will stop there. Let's explain through an example. This is a DFA. I will try to minimize it using the state equivalence method. Now this is the transition diagram. Now this is the transition table from this. Now we'll find the zeroth equivalent. What will be zeroth equivalent? Whatever non-final state, that will be one group. Whatever final state, that will be one group. Zeroth equivalent will be SC and B. SC is one group, B is another group. B is the final state, SC is the non-final state. Now we'll find the transaction from SC by A and B. From SC by A, where it is go, from SC by A to go to A, from C by A to go to C. And both are non-final. And by B, where it go, both go to B state and both are final. Here both are non-final, here both are final. If on same string transaction go to both final or both non-final, then we will say these are equal. So you can write ACR equal. In P1 also AC will be one group and B will be another group. And both P0 and P1 are equal. We have to find equivalent till two equivalent are same. Here 0th equivalent and 1th equivalent are equal. So we'll stop there and we declare that ACR equal. So construct the DFA. From this we just merge AC state, and from AC by A it will go to AC, and by B it will go to state B. And from B by A it will go to C transaction. Here we merge C with A, so it will go to AC state, and by B it will be self. This was a small example. I will explain with a different example. Let's first understand what is table filling method. Table filling method. Step 1. Draw a table for all pair of state Qi, Qj not necessarily connected directly. All are unmarked initially. Step 2. Consider every state pair Qi, Qj in the DFA where Qi belongs to final state and Qj belongs to non-final state or vice versa and mark them. Step 3. Repeat the step until you cannot mark any more state. If there is an unmarked pair Qi, Qj, mark it. If the pair del on Qi some alphabet and del on Qj some alphabet is marked for some input alphabet. Combine all the unmarked pair Qi, Qj and make them a single state in the reduced TFA or minimized TFA. Let's explain this step through an example. This is a DFA and this is the transaction table for this DFA. Now try to make a table that will contain all the pair Qi, Qj. Now this is a table, but you see here there is AA, BB, CC. Every state is equivalent to itself. So you don't need to find these three. You just cross these three. Now say here is BA state, here is AB. This is symmetric to this. BC, that is symmetric to this. So you don't need to find it again. If you are finding BA, then AB, both are equal. So you can cross it. Then AC, here C is there, this is symmetric to this, you can cross it. Now I got the table like this. Start from the second state and continue till last. Here start from the first state and continue till second last. Now here we got AC pair, AB pair, BC pair. So now step 1 is done. Draw a table for all pair. Now I got the all pair and all are unmarked initially. Next step 2, consider every pair QI, QJ if QI belongs to final and QJ belongs to non-final. Here what is final state? B is final. Now we'll mark final and non-final pair. So B is final, here B is final. B state B and state A. B is final, A is non-final, so we'll mark that. Then B is C. B is final, C is non-final, so we'll mark that. Now step 2 is done. Then step 3, repeat this step until you get all. Now we'll check for AC. AC. From AC by A where it go and by B where it go. From AC by A, it go to state AC. Is AC is marked before? No. Then by B it go to BB. BB is already equal. Now just check AC and AC both pair are non-final, non-final. If it will be final, non-final, then we'll cross it. But if both are non-final, non-final or both are final, final, then it is equal. Now we found that from AC by A it is going to AC, by B it is going to B state. So this is equal. We just mark this as equal. Now we found the equal state AC. Just construct the minimized DFA. This is the minimized DFA from this. So how we'll do the table filling method? First draw the table like this. Then mark all the final and non-final pair. After that whatever left, just check by some transaction by A or by B. To which state it will go, it is already crossed before or not. If it is already crossed, then it will be crossed. If it is not crossed, then this will be equal state. If you are not clear by this example, I'll explain more example, more bigger DFA that will get more clear. If any doubt, just ask me in comment. Thank you.